In a previous video, I showed you how you can pass parameters to a sub-procedure, which allows you to write reusable code. In another previous video, I showed you how you can call a number of functions which are built into VisualBasic.net. In this video, I'm going to show you how to write your own functions. Let's write a simple function to calculate how much somebody has earned based on their hourly rate of pay and how many hours they work. I'm actually going to start with a sub-procedure, but bear with me. My sub-procedure will have two parameters, the hourly rate of pay and the number of hours worked. To keep it simple, let's suppose you can only work whole numbers of hours. Here's the calculation. I'm using the decimal data type because it's the best choice for calculations involving money. It's the most accurate numeric type in VB.net. And the calculation is very simple. All I'm doing is multiplying the hourly rate by the number of hours worked. Finally, I need to do some sort of output. I could use a message box. And now to call the sub-procedure. I'll do that when the user clicks on the button. Of course, I have to pass parameters to this sub-procedure in order for it to work. For example, let's suppose that the hourly rate is £9.57 per hour and the number of hours worked is 20. That's a total of £191.40. Well, that's a sub-procedure with parameters, but we've seen that before. Now I'm going to turn it into a function, like this. I've changed the word sub to function, and VB.net has very kindly changed end sub to end function. And I'm now being told that my function doesn't return a value. This is what makes a function. By definition, a function is a subprogram which returns a value to its caller. It might and it might not expect input parameters. This one does, it has two parameters. The key thing is that the function returns a value to its caller. And I'm doing that using the return keyword. Now I can call my own function in exactly the same way that I can call a built-in function. Rather than using the call keyword, I'm going to do this. There's the name of the function. There are the two values I'm passing to it. And what comes back from the function, what is returned from the function, goes straight into this variable. This has the same structure as a call to a built-in function. Let's see if it works. Indeed it does. I could call my function like this. That's the function call, but the return value is being passed directly to the condition part of an if statement. I can call it like this. There's my function call, and I'm passing the return value directly to the message box command for output. And, just like a built-in function, I can do this. I've nested it inside another function to round up the result. There's the function call, and its result is being passed directly to the Math.Ceiling function. But perhaps it's a little easier to see what's going on with a function call like this. Now I should mention that it's important to control the data type of the return value by putting an as clause at the end of the function definition. I'm explicitly saying that this function returns a decimal value. This means that the calling program must be expecting a decimal value to come back, which mine does. Let's write another function, perhaps to calculate the area of a triangle given the size of its base and its height. This function is expecting two input parameters, both with the data type of double, and it will return a value with the data type of double. And here's the calculation. The area of a triangle is half of its base multiplied by its height. I could do the same calculation like this. It doesn't really matter, it will give me the same result. And, as before, I need to return a value. As I said, the definition of a function is a program that returns a value to its caller. Let's give it a try. A triangle with a base measuring 12 and a height of 20 has an area of 120. Of course, I could have just done this. Finally, let's do something a little bit more sophisticated. Let's write a function which, if I give it a temperature, it will tell me if it's cold, warm, or hot. This function has one parameter, temperature, which is an integer, and it will return a string. Notice how my function returns something on every possible execution path. I'll get a warning from the compiler as a green wavy line if there's a possibility that my function won't return something. Let's give it a go. A temperature of 12 is warm. 30 is hot. And 3 is cold. Why don't you try writing some functions yourself? Perhaps to calculate the cost of an online order, depending on the number of items ordered and how much it costs for each item. Or perhaps you could write a function to calculate the area of a circle based on its radius. Or a temperature checker, like mine, but with some alternative messages like freezing, very cold, cold, warm, hot, very hot. As you progress through this course, you'll see that being able to write your own functions is an incredibly useful skill.